Okay, this is for chemistry on level and pre-AP chemistry. This is the last example in the dimensional analysis notes. So whenever we learned about the mole, molar mass, Avogadro's number, and then this is the very last example, has some stars by it because it's special and a little different. Very important to understand for when we move on to stoichiometry, especially if you want to go on to AP chemistry. So the question says, how many atoms of oxygen are in 3.75 moles of carbon dioxide? We're going to start the problem the exact same way every single time. First thing is identifying our given and what we're looking for. Our given is 3.75 moles of carbon dioxide. I already have it written out for you. And then what we're looking for is atoms of oxygen. Just kidding, I put carbon in my stuff. It's atoms of oxygen. So, very important to note, one says carbon dioxide, one says oxygen. That is why this problem is starred, and that's why this problem is so important, because you can go back and forth between the two, and we're gonna learn how today. So, moles, like I said, is Grand Central Station. It connects everything, and so in this case, it also connects the stuff. So to work this problem, we're gonna jump back and do some concept stuff. So I said 1 mole is equal to 6.02 times 10 to the 23rd atoms, which is Avogadro's number. We have moles, we want to go to atoms. We're going to need Avogadro's number. But we have moles of carbon dioxide and we want atoms of oxygen. So first I need to know my moles of oxygen to then use Avogadro's number. So how can I switch from moles of carbon dioxide to moles of oxygen? Well, it's going to be with the formula, and we're going to talk about it because this is a crazy concept. So we're going to do it kind of with a dozen. So if I were to say that I had a dozen CO2 molecules and I wanted to know how many carbon or oxygen, a dozen is 12, and so you can just look at the parts. So I've drawn it out and I couldn't fit a dozen on here, so in this case, for this example, we're only using 4. But carbon dioxide, the formula for it is CO2, and it's drawn out like this. So I have 1, 2, 3, 4 CO2 molecules. Well, how many carbons did I use? Well, I only have 1, 2, 3, 4 carbons. So whenever I have 4 carbon dioxide molecules, or 4 moles of carbon dioxide, I also use up 4, I have 4 carbons. And then how many oxygens? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 oxygens. So it's all based off of the formula. If you look at the formula, I have CO2. If I have 1 of them, I have 1 carbon and 2 oxygens. If I had 2 CO2s, I had 2 carbons and 4 oxygens. So you're multiplying by their problem. So we can set this up in our dimensional analysis set. So with that in mind, that's how we're going to solve this. So if I know I have 3.75 moles of carbon dioxide, that means I also have 3.75 moles of carbon. But just like previously, I want to go to oxygen, and so with those, when I had 4, I doubled it and had 8 oxygens. So here I'm going to double this number to get to my oxygen as well. So work the problem the same way. We listed what we're given, what we're looking for, and then I'm going to start with my given every single time. I'm putting it over 1 just so I can see where my units are at. I have moles of carbon dioxide on top. I want to cancel out moles of carbon dioxide. I know the relationship to be true. For every 1 mole of CO2, I need 2 moles, I need 2 oxygens. So I'm using this ratio right here. I want carbon dioxide to go on bottom. So for every 1 carbon dioxide, I have 2 oxygens. Hopefully you understand how that works. And so then my units are going to cancel right here. And now I have moles of oxygen. And now that I have moles, I can go to Avogadro's number. I can use Avogadro's number to go to atoms. Because for every 1 mole of oxygen that I have 6.02 times 10 to the 23rd atoms of oxygen. So I need moles to go on bottom for units to cancel, and Avogadro's number to go up on top for units to cancel. Again, that is 6.02 times 10 to the 23rd atoms of oxygen. So your work would be 3.75 times 2, which is 7, times 6.02 times 10 to the 23rd, which 6 times 7 is 42. And so it's going to be 42 point whatever times 10 to the 23rd. So something pretty close in there for your answer. Hopefully that's making sense to you, and that's the last example problem. I'm going to start a new playlist to move on to the notes, and we're going to learn how to do chemical formulas, percent composition, things like that. So